All right, it's Tuesday, July 28th, and if you look at our agenda for the week, today we're going to do the iMaths lesson, section 2.2, which deals with functions. So in the syllabus yesterday, I explained to you that IB Math is divided into 4 or 5 topics. So here is all the IB subtopics that belong under the main syllabus topic of functions. So functions are simply a relationship between two quantities. All right. In mathematics, when we study functions, it's broken down into families. So you have functions that are linear. So when you graph them, you get a line. You have functions that are quadratics. When you graph them, you get a parabola. Okay, you have functions that are exponential or logarithmic, such as modeling the spread of the coronavirus. You have functions known as rational functions, okay, because the variable is in the denominator of a fraction. Okay, and that's just a few. You have cubic functions, you've got trigonometric functions. We're going to start with just learning the basic concepts of, again, what a function is, types of functions like one-to-one, composite functions, inverse functions, and what is known as the identity function. Then we're going to take a look at some of the function families in a little more depth. And then we finally look at taking these functions and transforming them. Now, transforming just means taking a function and sliding it up and down, flipping it right and left, flipping it up and down, or stretching it sideways or stretching it vertically. So that's where we're headed. That's our sort of our roadmap through the topic of functions. All right, to get to myimaths.com, if you didn't bookmark it yesterday, just type in So first, log into your My iMaths account that you set up yesterday. So I have a fictional student in here. First of all, you log in using the school username, which is Florence, and then the school password was multiply 18. All right, so we type that. Then you're going to put in your 3-digit username, your 3-letter password. So here it shows you have a lesson to do, functions 1, and an online assignment. So you'll complete each one of those. Now the lessons are set up and they'll show an example, how to do it, an explanation, and then it'll ask you some questions that you complete. Once you're done with that lesson, then you go to the online homework. The online homework you can do as many times as you want up to the due date in order to improve your score on that. All right, so to navigate through these pages here, here's the different parts of this list, and you can get to those by just choosing these numbers on the side of your screen. All right, it talks about what the objectives are. So we're going to interpret simple functions with inputs and outputs. We're going to use function notation as a way and other ways of describing functions. And then we're going to take a look at the connection between graphs and functions. All right, so I'm just going to click on input output. All right, it says watch this table here. So we have a list of inputs. Okay? So for each number in the input column, there is an output. Okay, so for example, 2, the output that goes with 2 is 5, etc., 11, 17. Now, what we're looking for is what's the connection between the inputs and the outputs. So we're looking for a pattern here that's taking these numbers, it's applying some kind of rule and creating these numbers. All right, so if we looked at this, what's happening is the input is getting multiplied by 2, and then 1 is being added to it, and that's creating the output. So this is the rule that maps an input to an output. So we're doubling and we add 1. All right, now if we take out the words input and output and replace them with x and y, this equation up here, so it used to be the output was equal to 2 times the input plus 1. Now if we replace those, okay, we're replacing the word output with a y, and we're replacing the word input with an x, then we get ourselves an equation. So that's the rule that describes how the input is related to the output. All right, and then we can fill in these other two values. 25. And then I hit mark it. Mark it in IB means correct it, right? Now we move on to the next part. Okay, there are many ways to describe the relationship between inputs and outputs. So all of these are legitimate ways of describing what's happening. Okay, the output connection to the input is double and add 1. Okay, y is connected to x by doubling and adding 1. The way that we usually talk about it, or at least in mathematics, is y is a function of x. So that means something is being done to x to create a new value called y. And here was the equation that we came up with. Okay, a function turns an x into 2x plus 1. And then the other language that you sometimes see is the word maps. So x gets mapped onto 2x plus 1. That's the same thing as saying 10 maps onto 25. This is your input and this is your output. So these are all different ways of describing the relationship between the input value and the output value. All right, complete this example. So I'm going to pause it. The missing y values. Y is the output and the function for this table. So what we're doing here is we're trying to figure out what's happening, what's being done to the x coordinate, the inputs, to create the outputs. And then once you've got that figured out, what's the missing y values? So I'll pause the video again and let's see if you can figure out what that is. And once you think you have it, then restart the video. All right, the rule was take the input, multiply it by 5, and subtract 5 from the result, and that would give you the corresponding. All right, using what we just talked about, inputs and outputs, we're going to fill in these values here. So we've got, to get your y value, you're taking 16, multiplying it by 5, and taking away 3. 3 gives us 77. All right, 17 times 5, 18 times 5, 3. Okay. All right, now what you can do is you can see a pattern here and how that pattern kind of relates to what's happening to this rule. If you look at the difference between these numbers, they are 5. So sometimes a function is described as a machine. Okay, it's a machine that takes an input value and creates an output value. So this is my crude drawing of a machine. Okay, a number goes in that takes the function takes the number, does this to it, and then the output of that number is your y value. So if 16 went in, then the y value that came out is 77. So we also refer to it sort of as like a machine where you're putting something in and something's coming out. So our next step is to type in the last two X values from the input table of the machine and see what happens. Well, we know what's going to happen. Pretty straightforward. Okay, we got 19 times 5, turns it into 95, out comes a 92. Okay, it's going through our machine, sort of like going down an assembly line. Okay, we drop 20 in as an input, turns it into 100, takes away 3, output. So these are all very straightforward examples of the basics on how a function works. It takes a value, does a rule to it, and creates a new value. So sometimes what we do is we know the X value and the Y values, but we don't have the function value. All right. So here we're going to end up with the X and the Y values and then figure out what's being done in this machine in order to create them. Okay, so I'm going to just pick an X value. Well, I think a pretty easy X value is 0. So when 0 went in, it gave us a 7. So 0 got mapped to 7. All right, and then again, I keep it simple. All right, 1 turns into a 7 and becomes a 14, right? 2 turns into a 14, then becomes a 21, okay? And just to see something different, let's type in a negative. So I'm going to put in negative in. All right, now we want to look at this and decide what is the rule that is taking these and creating the outputs. So pause the video, see if we can think about it, and then we'll come back and see what the solution is. I wanted to show you one hint here when you're doing these. It's the same what I did earlier. You're looking at what this common difference is. Now, this one doesn't apply because I didn't follow the same order. So we can just use these first three, and we notice that there's a common difference of 7. So something's happening with that 7, and when in the previous example, we noticed that whatever the common difference was, that was getting multiplied by the input, and then something else was being done to it. So let's see, if we multiplied 0 by 7, we'd get 0, and then to make it into a 7, I'd have to add. If I took 1 and multiplied it by 7, added 7, I get 14. 2 times 7, 21, add 7, 28. Negative 1 times 7, negative 7 plus 0. 7 is 0. So our rule here now, 7x plus 7. All right. So we want to come up with our rule here. So if I look at what the common difference is, you can see that each time it is 6. So I know my rule is going to be 6 times x, and then decide what do I have to do to create this. So 6 times 0, 0. I'd have to add 7 to create 7. 1 times 6, 6. Add 7, 13, etc. So we know that our rule here would be 6x plus 7. Okay, inputs and outputs, guys, don't have to be x's and y's. They can be anything. It's just 2 letters. Okay, it could be A and B. All right, so now you're just taking you've got the rules, and you're going to fill in the missing outputs based on using the rules. So I'm going to pause this, go ahead and work those out. So here it says the output is equal to P, 4, plus 2 times Q, which is 6. So our output here is going to be 10. P is 3. Q is negative 1. So 2 times negative 1, negative 2. Add those up and we get 1. Oh, not all correct. Well, because I didn't finish the rest of them. These two are correct. All right, now over here. When you're doing a table, it's assumed that the top numbers, the top row is always the inputs, and the bottom row is the outputs. When your table is drawn this way. Okay, when a table is drawn vertically, the column on the left is always assumed to be the inputs, and the column on the right is always assumed to be the out. So here it says take 10 and add 5t. So we'd have 10 plus 5 times negative 2, that's negative 10, so that's 0. 10 plus 5 times negative 1, that's negative 5, plus 10 is 5. 10 plus 5 times 0, 10 plus 5 times 1, 10 plus 5 times 2, 20. And again, you see the pattern of how you get what the common difference is. Each one of these is increasing by 5, which tells us what our multiplier is. Okay, our last table here, it says complete table if you have the height is 3 more than 5 times the width. So our height is, our width is 4, so 5 times our width would, would create 20, and then 20 plus 3, 23. Okay. 6 times 5, 30, plus 3, 33. 8 times 5, 40, plus 3, 43. And 10 times 5, 50, plus 3, 53. Now something kind of interesting here is if we look at our common difference as you go through this, it's 10. Yet it says 5. So why is that? So the reason why this is a little bit different, where we were increasing here by an amount of 10, and the reason that's happening instead of increasing by 5 is because the width is increasing. It's not counting by ones. It's not going from 2 to 3 to 4 to 5 to 6 to 7. It's counting by 2s. So 2 numbers from where you started would have been this occurring twice, which would give you the 10. All right. So had these gone in consecutive order, then 3 times 5 would have been 15 plus 3. This intermediate number would have been 18. 5 times 5, 25, plus 3, 28. And now you could see that it would fit what we've been discovering as 5 being the common difference. But since we were skipping a number, 10 became the common difference. So inputs and outputs can be graphed. And when we do it, the input is your x-coordinate, which is your horizontal axis, okay, and your y values go on your vertical axis. So every function has a picture that belongs to it. So I'm simply graphing that chart using, or those values using the function 2x minus or plus 1. And then you can see that these are our points on our graph. We got 0, 1, etc., 1, 3. So a function can also be described simply using a set of ordered pairs. And as I mentioned earlier, when we draw these, that's a line. So we call this a linear function. You know it's going to be a linear function when you have a common difference between the outputs. And this common difference is 2. Also is the slope of your line. 2 up, 1 over. Now in IB, the slope is referred to as the gradient. Okay, so the gradient and the word slope. All right, now we have a function that is going to be a parabola because the largest exponent is a 2. So we're taking our input, we're squaring it, 9, and then we're taking away 1. So that's going to give me 8. Negative 1 squared, positive 1, take away 1, 0. 0 squared, 0, take away 1, negative 1. 2 squared, 4, subtract 1. And then when we join those, we get a parabola. So that is a quadratic function. Now this next one is what is called a rational function, which is something you may not have talked about last year when I talked to Mr. Carlin about whether or not you guys covered this. Okay, what a rational function is. So in mathematics, the word rational is the same as fraction. So if you look at this function, the variable creates a fraction. That's what's known as a rational function. So these are all different types of rational functions. I could have anything I want. Okay, I could have variables on the top and the bottom. These are all different types of rational functions. Quadratic on the top, all different types of rational. They're fractions. Your function is an actual fraction. All right, now it says use 2dp if necessary. All that means is decimal places. All right, so to get our values, we're taking our 1 and we're dividing it by the input, which is 1, so that's easy. Okay, our input of 2 divided by 1, or excuse me, 1 divided by the input, which is 2, so that gives us 5/10. 1 divided by 3 gives us the repeating decimal 1/3. 1 divided by 4 gives us the decimal 0.25. 1 divided by 5 gives us the repeating 2, 2/10. And 1 divided by 10 gives us the decimal 1/10. And that's what the rational function looks like. Now, actually, every rational function has 2 branches. Okay, because of this part of the graph wasn't included, there would be another branch down here. And that's true for all rational functions. We're going to get more into rational functions in the latter part of this unit, so don't think you have to know every single thing about them. Okay, now this was referred to as a reciprocal function. You were just taking, these were the reciprocals of the top numbers. Remember, a reciprocal means you just flip the number. So the 2 as a fraction is 2 over 1, so its reciprocal is 1 over 2. 3 as a fraction is 3 over 1, so its reciprocal is 1 over 3. So this reciprocal function is a type of rational function. And there's lots of different types of functions. Okay, it's like languages. There's all sorts of different ways of describing something using a different language. Okay, functions are the same way. You can describe different shapes using different functions. All right, mathematicians sometimes find types of functions and how they behave more interesting than the actual input and output values. To study functions, we give the function a name, which in maths, now this website is from Europe. So you'll hear, instead of using the word math, it'll always use the word maths. Okay, so giving a function a name is just using the shorthand. It's a shorthand way of writing out an algebraic expression. Okay, so typically we name functions f, or you can use any letter you want. It doesn't matter. This is the function of the name. This is the function's name, I'm sorry. So it's like saying that this is function Fred and this is function Ginger. You can use any letters of the alphabet you want. The X simply means that's the input. This does not mean F times does not indicate multiplication like it does if we wrote like that. That means 5 times X. Okay, this is the input. Okay, so we could rewrite this if our original function that we talked about earlier on was double the input and add 1. Okay, and we wrote it like this. We said the output y was equal to 2 times the input plus 1. And then another way of writing that same thing was to take out the word output and put a y in, take out the word input and put an x in, and then we got an algebraic expression. And what the next one is, in function notation, you take out the letter y and you replace it with the name of the function. So f of x is equal to, and then the rest of this is the same, 2x plus 1. So f of x and y are the exact same thing. It's just different ways of expressing. So when we have our notation f of x, this represents our input. So in here, your input is now 5. So if the input was 5, the output would be 2 times 5 plus 1, 11. Here, your input is 12. So what is in the parentheses is telling you what the input is. Take that input and apply the rule that you called f to it. So if my input was 2, and my f rule was double the input and add 1, I'm going to double 2, 4, add 1, and get 5. All right, on this next page is just practicing using the inputs, understanding what this notation means. So 5 is our input, and the rule that we're using is f. So that would be 5 squared. You remember, you do your exponents first. So this would be 4 times 5 squared. That's 20. Your input is -2, and you're going to use the rule that's labeled with an f. So that would be 4 times -2 squared. Do the exponent first, +4 times 4, and that gives us, now our inputs are 9, and our rule has changed. So you're going to input 9 in for wherever there's an x. 12 squared, 144. My input is 9. 9 plus 3, 12. 12 squared, we already know, that's 144 plus 1. So that part we already know. We already know what this is. We did it right here. That's 144, so that's just 2 times that output of 144, which gives us... All right, now we're just filling in this table. The second row we're using function f, and the third row we're using function g. So you're putting a 1 into this equation and a 1 into this equation, and then putting in the corresponding values. All right, plotting a graph of a function helps see its features. All right, so to plot a graph of f of x, we choose some values, and then we find the corresponding function values. So when the values you choose, that goes in for your x, and then you take that and you apply it to whatever your rule is to get your output or your y values. And then we plot y equals f of x. Remember, those are the exact same thing. Okay, that was the one that we did earlier. And earlier when we wrote it, we said that y was equal to 2x plus 1. And y is the same thing as writing f of x, right? We know this is going to be a linear function because the largest exponent here is a 1. So now we're taking our 0, that's our input. So this would be, this first one is finding out what's the output when you put a 0 in. So that's 9 minus 2 times 0, 9. Okay, this would be g of 1. When you put 1 in, you get 7. This would be g of 2, that would be 5. This would be g of 3, etc. And then those make up your values. 0, 1 is mapped to 7. 2 is mapped to 5. 3 is mapped, 4 is mapped to 1. And then you just drag in these points and plotting those and checking your work. All right, once the graphs are plotted, then we can compare features. Okay, they're both linear functions because they're lines. One has a positive gradient. So remember, our positive slope is uphill. So f of x has a positive slope. From left to right, g of x is downhill. So we say that that has a negative slope or negative gradient. All right, once you're done with the different components of the lesson, then you're just going to go back up to your browser bar here, and it'll take you back to your homework screen. And now you're just going to click the online homework, and here's your 3 questions or 4 questions. You're just going to be filling those in, hit submit, and it'll grade it for you. If you want to improve your grade on it, then you can redo it after that. Okay, and that's it for today, guys.